Hello physical science student. Once again, we have some practice EDOC, but for this one, just like the previous one, just read it carefully and follow the direction. Just one note, 1 joule of energy or 1 joule of work is a combination of kilogram times meter square divided by second square. So when you see joule sometime, you might have to plug that in to cancel the unit. So just watch me do the first scenario in this example video and see how it's done. So here I'm looking for what is the force needed. So I type in here, force is what I'm looking for, question mark, right? What am I given? I'm given work is 100 joule of energy. But instead of 100 joule, I will put in this kilogram times meter square, which I'll change to in a little bit, divided by, and let me go tap, 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 tap. Sorry. Let me highlight this and do it as an underline so you can see it. And go down to the next line. Second square, and we change it from meter 2 to square by going format, text, superscript, and the same thing here, but we'll do that later because we still have one more thing to type. Okay, and then last but not least, what do I have? I have the displacement or distance. Displacement is basically the same thing as distance in a straight line, so in this case we assume it's a distance in a straight line is 5 meters. Okay, and then we'll go back here and square that by doing format, text, and superscript. Okay, so that's what we know and what we're looking for. So based on this, what equation would we use? We would look for force. So if we cover up force right here, what do we get? So if we were to cover up force, we would have the letter W above and the letter D below. So it'll be work divided by displacement is the equation. So with that, we're going to plug it in. So force is equal to work, which is in this case 100 kilogram meter square divided by second square. Okay, and we'll fix that later. And that is divided by, so I put it not a dash, or I can do the underline if you want, do the whole underline thing. Okay, and then take away the underline and go down and put the displacement. Oops, sorry. The displacement in this case is 5 meters. Ooh, okay, let me take the underline away from that one. Okay. Take that away too. So now what is force equal to? Okay, so what's 100 divided by 5? So I grab my calculator, do 100 divided by 5. You should know that is roughly 20. Okay. And the meter cancel with the meter square, so you still have 1 meter left. So it's kg m divided by second square. Okay, and we square all of that. And this is square. So what is force equal to? The force in this case will be equal to 20, and kilogram meter per second square, if you don't know, is what a Newton is. So that whole unit right there, kilogram meter per second square, is Newton. So that's how you do every single problem. List what you know and what you don't know. Rearrange the equation to find what you're trying to look for, in this case F. So let me just review that with you for a little bit. If I'm looking for work, if I cover that up, what do I have? I would have F times D. So if I'm looking for work, the equation will be equal to the force times the displacement or distance. If I'm looking for displacement or distance in a straight line, I would have work divided by force. So if you were to take a few seconds to look at the next question, how much work is done? So I'm looking for W, I would take the force times the displacement. So with that, here's my force, and I'm going to multiply it by the displacement. When you look for work, the unit is joule. So if you can't cancel unit and it's complicated, just go ahead and plug it in as it is, Newton times meter. And when you have Newton times meter, that is simply joule, okay? And then if you go to the next one, if you look at, say, Blanche doing the work here, how much work is done? Once again, if we're looking for work, we would have force times distance. if you go down to Mr. Alvarez, very famous physicist, and if you look at what he's trying to find, you're looking for how far is going to be distant or displacement. So we go back up. If we cover up D, what we would get? We would get W divided by F. So in that case, we would plug in W divided by F. Okay. So with that, when we get down here for power, I'm just asking you for power. If I cover up P, what would I get? P is simply work divided by time. So how powerful you are is how fast you can do your work. Like Superman can do a lot of work in 1 second. It might take Mr. Wu like 10 hours, right? So he's more powerful than me. A train can carry a lot of stuff in 1 minute, and it'll take someone in a shopping cart like 10 days. So the train is more powerful. So once again, if you cover P, power is simply work divided by time.